Okay, flipping over. Triangle ABC and triangle A prime, B prime, C prime are shown below. Which algebraic representation best describes the effects of the dilation? Are you on this right page? Ooh. Oh no, I missed one. Now on to number 5. So which algebraic representation best describes the effects of the dilation on triangle ABC to create triangle A prime, B prime, C prime using the origin as the center of dilation? So first thing, look and see what happened. So our old image is the smaller one, and we know that this larger triangle is our dilated figure because it's got those hash marks next to each letter. So first of all, look and see what happened. Did it get larger or did it get smaller? Okay, so it got bigger. So that tells us that our scale factor should be bigger than 1. That'll help us eliminate some answer choices. So since our figure got bigger, our scale factor has to be bigger than 1. So already, can I eliminate any of those? So I can eliminate A, good, because it's got 1/2. And D's got a bunch of problems. So D says 1/2 times X and then 2 times Y. Remember, if you're doing dilation, you're multiplying each X and Y by the same number. So D is out. So then what's wrong with C? It says we're adding. If we're dilating something, the size is changing, we're multiplying it. So it's got to be B. Okay, on number 6, triangle ABC is graphed on the coordinate plane as shown below. If triangle ABC is rotated 270 degrees clockwise about the origin, which of the following statements would be true about the new A prime, B prime, C prime? So it's not looking for points. All my answer choices, it's just a lot of vocabulary. So A says triangle ABC and A prime, B prime, C prime will have the same orientation. What's orientation mean?
The side, the facing?
Good, the direction a shape is facing. So it'll have the same orientation. So it's saying if you turn that triangle 270 degrees, will it still be facing the same direction? No, because we're turning it. It won't face the same direction. B says triangle ABC and A prime, B prime, C prime will not be congruent. So congruent means same size and shape. So they'll not be congruent. If all we're doing is turning that shape, should it still be the same size and the same shape? So it will be congruent. So that one's out. Then C says triangle ABC and A prime, B prime, C prime will not have the same orientation. So basically, they won't be facing the same direction. Sounds good. Let's check D. So triangles ABC and A prime, B prime, C prime will have the same orientation and they'll be congruent. What part of that sentence is not right? That orientation. So C has got to be our answer. Okay, number 7, rectangle PQRS is shown. PQRS is shown. If rectangle PQRS is transformed to rectangle P prime, Q prime, R prime, S prime, which scale factor can be applied to create congruent rectangles? So same size, same shape. So we know if I have a scale factor bigger than 1, then my shape will get bigger. Scale factor less than 1, it would get smaller. So we are looking for a scale factor that's going to make the same size. So basically it's going to stay the same. So a scale factor of 0. If we multiplied every single one of these points by 0, what would happen? it would disappear, I guess. Yeah, and it would kind of be smaller. So scale factor of 2b, what would happen if we dilated by a scale factor of 2? It would get bigger, so we can't do that one. C, a scale factor of 1/2. It would get smaller, so that's not what we're looking for. Scale factor of 1. Because if you multiply anything by 1, what do you end up getting? The same answer, the same number. Number 8, triangle in quadrant 2 is shown below, which transformation would create a new triangle that is not congruent to the original. So not the same size, not the same shape. Good. So A, if we rotate a triangle 270 degrees, all we're doing is turning it. So we'll still have the same size triangle, same shape. It'll just be turned around on the coordinate plane. If we translate, what are we doing? We're just sliding something from one side of the graph to the other. So it's going to be the same size, same shape. If we reflect it, same thing. Nothing's happening to the shape size-wise or shape-wise. It's the same, except it's just flipped itself over. Dilate. Dilate's the only one that will not be congruent to the original.